Um, we're going to look at future and present value of, I should say compound interest. I didn't write that in. Compound. Oh, no. It doesn't. Compound interest. And we're going to relate the two. So this is the common future value formula. They might also show you a formula that looks like, and let's actually take a look. You got P equals A
divided by
1 plus I to the power of N, or P is equal to A.
Just a negative. It's the same.
Yeah, exactly. It's the exact same. Good. So it's good that you noticed that already. So these two things are already the exact same. So there's really no need to memorize both. One of them is sufficient. And this formula is actually just isolating for P in this question. So if we go about actually isolating for P, we had A is equal to P times 1 plus I to the power of N. Think of this like there's multiplication, so in order to move it to the other side, we have to divide by it. So we end up with P is equal to A over 1 plus I to the power of N. So really no need to memorize any other formulas. We memorize the one as long as we can manipulate it. And even then, we don't really have to manipulate the formula in its letter or variable form. If we have a question, let's say, we got an account that gives us 5% interest per year, compounded, I'm going to say semi-annually, okay? And really, probably just type this, it'll go much faster. And we're going to say that the person wants to earn, so we want to earn $10,000 over 10 years. And do I need anything else? What do I invest? What do I invest? Okay. So they gave us a bunch of requirements here. And let's start with the actual original formula. Technically, usually the original formula is set equal to 8 to find a future amount. But it doesn't. Yeah, we can still find the present value from that, this being P. What we do is we plug in all of our values for our other variables. Okay. And when we do that, we can just isolate for P at the end, not having to use a whole new formula to memorize or anything like that. So they want to have $10,000 at the end of this. So what that means is that is the future amount of money they want to have. So this is going to be our A value in this question. Okay, and again, there's technically two other things. We have your R for your interest rate, compound period, and number of years we got to figure out. How long did they want to invest for?
They 10 years.
10 years, okay, so that's going to be 10 in this one. The compound period, what was the compound period?
Semi-annually, so 6 months.
Okay, semi-annually, that's right. So every 6 months. So that means, and because it's per year, what that's asking is you have to relate those months to a year. So that means it's going to happen twice in a year. Okay, so our compound period is going to be 12. Just like monthly, it happens 12 times per year. And whenever they give you an interest rate, it will most likely say per year when they're talking about that. And then the interest rate itself was 5%, which has a decimal 0.05. Very generous interest rate. So we have an A value, and the I and the N we need to calculate. I is your R over your C here. So let's calculate what your I would be. 0.05 divided by 2. I think I got it that time. There you go. So when we divide it, we get this value. And then our N, so the number of periods, is your years times your compound period, which was 10 years times twice a year. So this is going to happen 20 years over the life of this, this account, you could say. Okay, so we have our values. Our A is now going to be our 10,000. The P is going to be the unknown in this question. 1 plus, and when we add those together, we know 1's just going to replace this, so it's 1.025. So we just kind of did an extra step there. And our N, the number of periods, we figured out was going to be the value of 20. Okay. So now we can actually calculate this, and when we have that value, we can kind of move it over in the end. So 1.025 to the power of 10. Gives us a wonderful number. Okay. Now I could write that in, but instead of writing that all in, because it's such a long decimal and it goes on forever, I'm going to show you how I can just tactically move this over to start, and then we can put everything in the calculator. So we have 10,000 divided by what was over there, which was 1.025 to the power of 20, which is pretty much that present value formula if you remember. Okay? So this way we can put it all in the calculator in one step and be extremely accurate. We're looking for 10,000 divided by that value. And it looks like we would have to, or let's talk about what number we get. 781198. So 781198. My mistake was, whoops. See this value here? I put it to the power of 10 for 10 years, but
it's 20.
Yeah, that's right. So it should be 20. So let's scrap that value, and we should get 10,000 divided by 1.025 to the power of 20, which is better because it means we're going to invest less money. There we go. 6,102.70. So 6,000. That's good. 6,102.70. Perfect. So that's the amount we got. And that amount, what that means is if 10 years ago, say we wanted to have 10,000 now, we would have had to invest $6,102.70 for this account to have given us 10,000. So if we invest that amount now, in 10 years we will have $10,000 in that account. That's what the present value is telling